At the end of this video, you should be able to describe 2 lines of evidence for Earth's rotation and explain how the change in apparent positions of constellations provides evidence of Earth's rotation and revolution around the Sun. Chapter 26, Section 2, Movements of Earth. Understanding the basic motions of Earth helps scientists understand the motions of other bodies in the solar system and the universe. These movements of Earth are also responsible for the seasons and the changes in weather. The rotating Earth. The spinning of Earth on its axis is called rotation. Each complete rotation takes about 1 day. The most observable effects of Earth's rotation on its axis are day and night. As Earth rotates from west to east, the sun appears to rise in the east in the morning. The sun then appears to cross the sky and set in the west. At any given moment, the hemisphere of Earth that faces the sun experiences daylight. At the same time, the hemisphere of Earth that faces away from the sun experiences nighttime. The Foucault Pendulum. In the 19th century, the scientist Jean-Bernard Léon Foucault provided evidence of Earth's rotation by using a pendulum. He created a long, heavy pendulum that rocks back and forth by attaching a wire to the ceiling and then attaching a weight to the wire. Throughout the day, the bob would swing back and forth. The path of the pendulum appeared to change over time. However, it was the floor that was moving while the pendulum's path stayed constant. Because the floor was attached to Earth, one can conclude that Earth rotates. A Foucault pendulum is shown in your textbook. The Coriolis effect. Evidence of the rotation of Earth can also be seen in the movement of ocean surface currents and wind belts. Ocean currents and wind belts do not move in a straight path. The rotation of Earth causes ocean currents and wind belts to be deflected to the right in the northern hemisphere. In the southern hemisphere, ocean currents and wind belts deflect to the left. This curving of the path of wind belts and ocean currents is caused by Earth's rotation and is called the Coriolis effect. The revolving Earth. As Earth spins on its axis, Earth also revolves around the Sun. Even though you cannot feel Earth moving, it is traveling around the Sun at an average speed of 29.8 kilometers per second. The motion of a body that travels around another body in space is called revolution. Each complete revolution of Earth around the Sun takes 365 1/4 days, or about 1 year. Earth's orbit. The path that a body follows as it travels around another body in space is called an orbit. Earth's orbit around the Sun is not quite a circle. Earth's orbit is an ellipse. An ellipse is a closed curve whose shape is determined by 2 points, or foci, within the ellipse. In planetary orbits, one focus is located within the Sun. No object may be located at the other focus. Because its orbit is an ellipse, Earth is not always the same distance from the Sun. The point in the orbit of a planet at which the planet is closest to the Sun is called perihelion. The point in the orbit of a planet at which the planet is farthest from the Sun is called aphelion. As shown on the screen now, Earth's aphelion distance is 152 million kilometers. Its perihelion distance is 147 million kilometers. Constellations and Earth's motion. Evidence of Earth's revolution and rotation around the Sun can be seen in the motion of the constellations. A constellation is a group of stars that are organized in a recognizable pattern. In 1930, the International Astronomical Union divided the sky into 88 constellations. Many of the names given to these constellations came from the ancient Greeks more than 2,000 years ago. Taurus, the bull, and Orion, the hunter, are some examples of names from Greek mythology that have been given to the constellations. Evidence of Earth's rotation. If you gaze up at a constellation in the evening sky over a period of several hours, you may notice that the constellation appears to have changed its position in the sky. However, the constellation's movement has not caused the constellation's change in position. The rotation of Earth on its axis causes the change in position. Thus, Earth is moving, and the constellation is not moving. Evidence of Earth's revolution. A constellation's position in the evening sky will change not only because of Earth's rotation, but also because of the Earth's revolution around the Sun. Over a period of several weeks, at the same time of the evening, a constellation's position will appear to change, as is shown on the screen now. But Earth's revolution around the Sun causes the constellation to have different positions in the evening sky over a period of several weeks. As Earth revolves around the Sun, the night side of Earth faces a different direction of the universe. Thus, different constellations appear in the night sky as the seasons change. At this point, you should be able to describe two lines of evidence for Earth's rotation and explain how the change in apparent positions of the constellations provides evidence of Earth's rotation and revolution around the Sun.